Hello, it's Mr. Allred here, and we're going to talk about graphs and functions to start off with. And I just want to kind of relate the two together. So first of all, we've got a graph here, and I say when reading graphs, make sure you pay attention to how each axis is labeled. So sometimes you might be familiar with the material, sometimes you might not. But the title of this graph, if it has one, is Speed of Car Leaving Starting Line. But we have two axes down here. We have the bottom axis, and it's the time, and that little s means it's in seconds. So as we come across the bottom here, we have 0 seconds, 1 second, 2 seconds, 3 seconds, so on. And then the other axis said speed in ms. So I would say that is meters per second. So maybe it's like a toy car or something else. I'm not sure. Remote control. Let's see here. But reading it on the other axis, 0, 10, 20, 30, 40, all meters per second. So you kind of have to interpret the lines that are there. So do notice if you're reading this thing, it starts off from 0 to 10 over here. It looks like it's jumping by 2. So as we go up to the first little line, it'll be 2 meters per second, 4 meters per second, 6 meters per second, and so on. So pay close attention to those. So we're going to look for the relationship here and see if we can answer some questions there. So the first question I have down here, how fast is the car traveling 2 seconds after starting? So I come over to 2 seconds and I will follow this up, and we may have to estimate a little bit, but right here at 2 seconds, it looks like we're at 2, 4, 6, maybe 7. So I'm estimating that. But it looks like I'm going to use 7. Was expecting that. 7 meters per second. Sometimes the tablet does odd things. Okay. The next one, let's see here. How fast is the car traveling 5 seconds after starting? So let's see here, 5 seconds. So we'll come over to 5. And I just want to come up here to where it touches. So at 5 seconds, we have 30 meters per second. And then the next question, how long does it take the car to reach 20 meters per second? All right, so let's see here, 20 meters per second. Let's see if we get some other colors here. We got red. I don't know how good that will do. But 20 meters per second is over here. So we're trying to find the place that it kind of works with. And if I go down here, I'm following this across the 20, and it looks like I would call this 4.2 if you look at that. So 4.2 seconds. In that case, since I was asking a slightly different question. Let me bring this down just a little bit to let's see the last question. How long does it take the car to reach 40 meters per second? I don't think that's the highlighter. Let me see if I can get the highlighters. Yeah, the highlighters. Purple. 40 meters per second. So up here is 40. I'll come over close in my head. Looks like I'm about there. I'm going to estimate 5.6 seconds. So let's see here. 5.6. I don't even see that purple on here. Let's just use that purple. Ew. Hold on. Learning new colors as we go. Guess we'll just go back to blue. We said 5.6 seconds. But reading the graph carefully so that we know we're going to the right place, because some of these questions were asking us to go for the time axis across the bottom and read from there, and some of them were asking us to read from the speed axis. So just kind of keep those in your head while you're looking at the graph. Alright, so reading graphs usually isn't too intimidating. But now we're going to talk about functions and domain. and how these relate to graphs. But a function is a formula used to model the relationship between two varying characteristics. So in that previous graph, they were relating or comparing time and speed and how they relate to each other. Usually with a function, we think of it more of as a equation, so to speak. But let's see here. The example I have down here is U-Haul rents a truck for $30 plus 25 cents per mile traveled. Write the function to determine the total cost of renting the truck based on the number of miles traveled. So this is my introduction to functions, so you may not be able to do this at all. So let me kind of give you all the information here. So first of all, we're going to write a function, and we need a certain notation. The generic, if you take algebra, is to call a function f of x, where x is an input, and the f of x is an output. So f of x is an output, sometimes called y in our graph, if you think about that in the algebraic sense. And usually we relate this to some type of formula. But we can give them any type of names we like. So f here is the function name, but since this thing is talking about cost, I'm going to call my function c for cost. And since the thing that's going to be changing whenever we work on this, the one of the characteristics that differs from time to time is the mileage, I'm going to call it c of m. So this is cost for miles traveled. Okay, so you're going to see this notation quite a bit in this unit, so kind of get used to it. F of x, if you're familiar with it with an algebraic or function notation, we can use any variables there we want. Okay, so with this, what we're going to do is we're going to write some equation for it, and the easy way to do this one is to say that it's going to be the $30 for just renting the truck, and then we're going to add to it 25 cents for every mile. Okay, so $30, and then plus every mile will be an extra 25 cents. So the input variable is m, and the output is considered the cost. Okay. One thing we always kind of do with this, or need to make sure we understand, is something called domain. And this is the values the function works for. So we usually need to state that. So in this case, we'll say the domain would work for what's the least amount of miles we could travel. And well, since m is our variable, we'll say m cannot be less than 0. So we'll say m is greater than or equal to 0. That's usually how we state the domain. Because we could drive as much as we want in this scenario. There's probably some realistic limit. But in this case, what we're really saying is when we talk about domain, are there any numbers that just don't work? So we're not going to drive a negative number of miles. Okay. In some scenarios, negatives might make sense, but not in this one. So what we're doing here is we're relating the miles traveled to the cost it's going to take to rent this truck. And what we're saying, and you got to get used to the notation, but what we're saying is we can't travel less than 0 miles. Now, keep that all in mind, and we'll go to this example here. Well, we'll finish up with this. It says calculate the cost of renting the truck to travel 350 miles. Now, this is something you could probably do without ever writing down this formula, but let me show it to you in the function notation. So our cost was C, and whenever we want to plug a number in, we're going to replace our variable with that. So this is the cost to travel 350 miles. Okay, so that's the $30 plus 25 cents for every mile, which there's 350 of those. So you pick up a calculator like I'm doing here, and the cost for 350 miles will be 25 cents times 350 plus $30, and in this case I get $117.50. That's supposed to be a decimal, not a comma. Let me clean up my dollar sign too. But this is the cost to travel 350 miles. Okay. So we just got to get used to that function notation. Even if you can't write the formulas yet, that's fine. Okay. The next thing we have here is another example. Yes, another example. Bobby needs to install 60 security systems before he can go on vacation. He can install 4 systems per day. Write a function to determine the number of systems left to install after so many days. So, this one will be a little bit different than the other one, but I'm going to use, I'm going to call my function S for security systems, and I'm going to let the variable be D for days. And you could use big D or little d. You can still use F and X and Y and all those things. But I like for my functions, if they're related to an application, to line up and make a lot of sense. So let's see here. He starts with 60, and what happens is he's taken off 4 every day. So 60 minus 4 per day. Okay, see if that makes sense. And in this case, the domain might be a little interesting, because the domain here would be the fact that he can't do less than 0 days, can he? Now, let's say here, is there a limit to how long this works? Because if we put in too big of a number for D, we're going to eventually be subtracting more than 60. So if we put in 100 days, that means he has negative systems to install, which doesn't make a lot of sense. So I'm just going to know, and just kind of show you a little bit, that he cannot be left with less than 0 systems, and that's the output. So as I solve this thing, and we'll work on this a little bit later, but divide by 4, I believe we're going to say that I apologize for that X there. That should be a 0. I think I said 0. But this function, this calculation, only works between 0 and 15 days. We're not going to put any negative numbers in there. That just wouldn't make sense. And if we go beyond 15 days, he's already installed everything. Okay, so that doesn't make any sense to go past 15. Okay, so just kind of keep this in mind, that the values for D, the number of days, only makes sense if it's between 0 and 15. And the last question down here, how many systems does he have left to install after 8 days? Once again, I think you would probably have no trouble answering this question without any equation or function knowledge based off of the description up there. But we're going to say S of 8, which is 60 minus 4 times 8. So we're just plugging that in. So that's 60 minus 32. I think I know what that is. Yeah, it's 28. So basically that's 28 systems, security systems, left after 8 days. Okay. So in the future videos, we're going to work on different types of functions as far as how to write those algebraic things that are kind of scary right now, and how to calculate them. So you have that to look forward.